Okay, welcome, ladies and gentlemen. Today we are going to continue on with some trig. So we did some SOHCAHTOA and some Pythagorean theorem already, and that's review. Like that's nothing new. What we're going to do today for some of you is going to be new. For some of you, it should be a bit of review. Depends on whether you had 10 academic or 10 applied. So what we're going to do today is we're going to look at how about we do the sine law. Okay. So sine law is what we're going to work on today. Now, if we think back to SOHCAHTOA and stuff, remember what we've had so far is we've done Pythagorean theorem, so c squared equals a squared plus b squared, and we've done primary trig ratios, so sine, cos, or tan of theta is equal to first letter over second letter. Now, these are really, really handy and they're great to use, but they have one major restriction. The restriction is, of course, that these are only available for right triangles, right? So these are only available for right triangles, which means that there's a whole suite of triangles. If the triangle is not a right angle triangle, we can't use primary trig ratios and we can't use Pythagorean theorem. So what are we going to do when a triangle is presented to us that's not a right angle triangle? Well, in March is the sine law, and later to come, of course, is going to be cosine law. Later, right? These are the ones that we're going to have to rely on if it's not a right triangle. So I'm just going to present them to you. So there are two forms of the sine law, and you can always stick with one, but it's nice to remember that there are two forms, and one is often easier to use than the other. But as long as you're careful with your algebra, it doesn't matter which one you take. So I'm going to do variant one. I'm just going to list them out, and we're going to do some examples. That's the easiest way to go with it. So variant one, and I'm going to say this is most useful for sides as unknowns. So if we're looking for a side length, okay, this is the variant that is going to be most useful to us. So I'm going to write it as a over the sine of a equals b over the sine of b equals c over the sine of c. Now, notice that on the tops and the numerators here, these are all lowercase, and in the denominator they are all uppercase. And the case is really important, and we're going to get to that in a moment. But it's really important to know that the case of the letters has a particular meaning when we're talking about trig. And I'm going to write out variant 2, and it's going to look extremely similar, almost identical, in fact. And this is when we're looking for the angles as our unknown. Okay, so if we're solving for angles, this is the easier variant to use, although they'll both work. And so it's pretty much the same thing, but we're going to turn it upside down. And so instead of being a over sine a for variant 2, we're going to have sine a over a equals sine b over b equals sine c over c. Okay, so this is useful if we want to find our sides. So is a side as the unknown. And this guy down here, well, it is useful for when it's the angle that is the unknown. Okay, so those are the two variants. Now, notice that it's not positional that matters. It's not like the numerator is always uppercase or lowercase. The uppercase is always going to be bundled with the sign, and the lowercase is always going to be singular. It's not going to have an operator on it. So that is going to take me as to a little bit of an aside. Okay, so I'm going to call this an aside. And what I want to do is review the naming of triangles. Okay, and this ties in exactly to what we have up here. So if we think about any old triangle, so imagine that I had a triangle that looked like this and like this and like this. So here's a triangle. Notice it's not a right angle triangle. It is just a triangle. I haven't said, kind of looks like it might be equilateral, but it doesn't have to be equilateral. It is any triangle. Now, when it comes to labeling our triangles, cases, as in upper and lower, matter. The points on the triangle, hopefully you remember what those are called. Think about it. Starts with a V. They're called, this is a vertex, this is a vertex, vertex. Collectively, these are vertices. Our vertices have to be labeled with uppercase letters. So I'm going to call this A, this B, this C. So it's important to know each vertex is labeled two L's, I think two L's, I don't know, uppercase. Okay, so vertices are always labeled uppercase letters. Now, imagine that you were talking to someone and they had a picture of this triangle labeled ABC, and you had the same picture of the triangle labeled ABC, and you wanted to describe a particular side to them. And so you wanted to say, hey, I want you to know about this side. So you and I can see, like we're looking at the same thing. If I wanted to know what this side was called, so I wanted to tell the other person, hey, that side there, what are we going to do with it? That's the same color, I think it's pretty close. How could we call it? Well, one way we could call this side is we could say this is side AB, right? So side AB on the triangle, it's like, oh yeah, that's the one that joins A and B. Alternatively, or you could also call it BA, and we would still be talking about the same side. But if we wanted to reference it in a formula, having multiple variables for one thing is not always a great idea. In comes the naming convention that this side would be called lowercase c. And so how it works is it is the lowercase letter of the opposite vertex, right? So this is uppercase C, this is lowercase c. This is uppercase A, so this side down here would be lowercase a. This is uppercase B, so this side over here would be lowercase b. So each vertex is labeled uppercase, and also notably, each side is labeled, let's do that one with just one L. No, I think it's got to be two. Each side is labeled with, not yet, with the lowercase of the opposite vertex, okay? And that is the convention. So if this is C, this is C. This is B, this is B. This is A, this is A. And that way, if we said, oh, side CB, you could say, well, yeah, side A, right? And it's just more efficient. That way we just have one variable when we have to name a side as opposed to having two variables. So that's really, really important. So let's just kind of, I'm going to draw another triangle up here, and we're going to just kind of do a really quick review to make sure that we're down with that. So imagine that I said that that's not even joined up, but whatever. So if this was triangle D, F, and R, right? Go ahead and label the sides. Pause the video really quickly, label those sides off for me, and then come back. Well, welcome back. Well, obviously this side here would be lowercase d, this would be lowercase f, and this would be lowercase r. And so that's really important. So that's the convention for naming sides on a triangle according to the vertices. So what this would mean on these trig ratios, okay, and these are also trig ratios sort of, what we're going to have is the side lengths are in the numerator, right? Because the lowercase letters, which represent side lengths, are in the numerator. Whereas down here, the uppercase letters are in the numerator. So those are the angles that are in the numerator. The general rule of thumb, okay, kind of the takeaway from this when we're working on this, in general, put what we are looking for on top, right? So if I'm looking for sides, I want the variant that has sides on top. If I'm looking for angles, I want the variant that has angles on top, okay? So these are the two variants. So variant 1 Variant 2. This one's for sides because the sides are in the numerator. This one is for angles because angles are in the numerator. Okay, so that is a rundown of basic sine law. So now, question is, how is it that we actually make use of that? How is that helpful to us? Well, I'm going to start out by just doing some examples here. Okay, so imagine that we had the following triangle. Imagine that we had this triangle here. So we got a triangle, and maybe we know that this angle here, it looks to be, that's like 75 degrees. And we know that this angle down here, well, it's, I don't know, 20 degrees. And we know that this side right here, it is, I don't know, how about this side over here? This side here is 10 meters. And this side over here is, well, that's what we're interested in. I would like to know what that side length is. Okay, so we look at that and we think, oh, can I use Pythagorean theorem? Well, first off, we only know one side, so we definitely can't use Pythagorean theorem. But it's not a right triangle. So given that it's not a right triangle, that means that we can't use Pythagorean theorem anyways. Similarly, because it's not a right triangle, I can't use SOHCAHTOA, because SOHCAHTOA primary trig ratios are only useful to us in the case that we have a right angle triangle as well. So we're going to use sine law. And here's how I'm going to do sine law. I'm going to go ahead and I'm going to first off label off all of the vertices. And it doesn't matter where you put the letters. For sine, I'm not going to use, well, I can use F, sure. It doesn't matter where you put the letters. What we're going to do is we're going to have to put the uppercase on the vertices, and then I'm going to label off the lowercase. So this is lowercase f, this is lowercase a, and this is lowercase b. And again, the letters don't really matter. It's the ratios that matter. So if we think about sine law, I am looking for a side length. Okay, so I'm looking for a side length. That means I'm going to write the sine law variation that has the side lengths on top. So I'm going to do a, b, and apologies, I used f by accident. So I have a, b, and f. The order doesn't really matter. It's where they correspond that matters. So a, b, and f are in the numerator because we want a side. So the side's the numerator. And then this is going to be the sine of a. This is going to be the sine of b. And this is going to be the sine of f. Okay, so there it is. Now, I'm going to fill in everything that I know, including any variables. So lowercase a is 10. All right, so that's going to be 10 in the numerator. And uppercase a, that's this vertex over here, so it's 75. So it's going to be the sine of 75 equals lowercase b. Well, lowercase b is x, so I'm going to put in my x over my uppercase b. My uppercase b is 20 degrees. Okay, 20 degrees. Oh, careful! It's going to have to be. Let's undo that. It is going to be not just 20 degrees. It's the sine of 20 degrees. Okay, so the sine of 20 degrees equals. Well, there's nothing for f, so I'm just going to leave it as f. And there's nothing for uppercase f either, so it's just the sine of uppercase f. Now, here's what we have to have after we have gotten to this step. What we need to look for, it's super important. If you don't have it, you can't progress. I have no idea what color this is. You have to have this. You have to have a complete ratio. We have to have a complete ratio. And what I mean by a complete ratio is a ratio that, there's a ratio, there's a ratio, and there's a ratio. Those are our three ratios. We need a complete ratio. That means one that has values populated in both positions. Okay, this is a complete ratio because it has a number and it has a number. This is an incomplete ratio because it has a variable and a number. This is a useful one that it's got one thing populated. And then we have this one over here and it has nothing populated. So if it has nothing populated, I can't do anything with it at all. Okay, if there's nothing populated, I can't use anything. But what I have to have is a complete ratio. And so as long as I have a complete ratio, in theory, I should be able to make some progress. So when we're here, so we always need a complete ratio and at least one ratio half complete. Okay, so here's our half complete ratio. This guy's half complete. Which is good. So we only have one variable. So what we're going to do is we can choose any two ratios. Now it's nice because these two are side by side, but if this ratio had have been, f and sine 20, it's okay. We can choose any two ratios. This equals and this equals means that this one and this one still have to be equal as well. So as long as we have a complete ratio and a half complete ratio, we can progress. So what we're going to do is we're going to take our complete ratio and our half complete ratio. Okay, so I'm going to take those two things right there, and I'm going to say, all right, so I've got 10 over the sine of 75 is equal to x over the sine of 20. Okay, so I'm going to take those and pull those out. Had it been this one and this one, I'd have taken those similarly and put them side by side. So here we go. We have our complete ratio, our half complete ratio. I know that when I'm done, down here somewhere, I'm going to want something that just says x equals, right? I want to get the x all by itself. Well, what's happening to x right now? Well, according to this, x is being divided by the sine of 20. What's the opposite operation of division by the sine of 20? Well, of course, it is multiplication by the sine of 20. So if I want to keep it balanced, I'm going to have to do multiplication by the sine of 20 on this side as well. So this one and this one, they're going to divide out to be 1. They're going to cancel each other out. And over here, we're going to have that x is equal to the sine of 20 degrees, that's not degrees, there's a degrees, times 10 over the sine of 75 degrees. And I can go ahead, that's an expression. Those are all numbers, and I can type that directly into my calculator. So I'm going to grab my calculator, and I'm going to make sure, it's really, really important anytime we're doing trig, that we have to have our calculator in degrees. Mine's not, so I'm going to have to go down here and say, all right, go over here, get into degrees, enter. All right, so now I'm in degrees, and I can type this in. Now, according to how your own calculator works, you have to know how it works. On this one, I can type, okay, it's the sine of 20 times 10 divided by the sine of 75. Close that bracket off. And we're going to find out that, hey, that unknown side, side x, is 3.54. So I found that value. Here it is. It is 3.54 is the unknown side that I was after. I don't recall if I had units. I did meters. So 3.54 meters. Okay, so that is a really basic lesson on how to do the sine law. I'm going to stop this now, and then I'm going to put up another video in a bit that's going to do a bunch more examples, and we'll do examples of how we find an angle, not just a side length. Okay, thank you.